we're going to switch now to Julia, I believe. And that is Haiying Wang. Haiying is an associate professor in the Department of Statistics at the University of Connecticut. He obtained his PhD from the Department of Statistics at the University of Missouri in 2013 and obtained his Master of Science from the Academy of Mathematics and Systems Science at the Chinese Academy of Sciences in 2006. His research interests include informative subdata selection for big data, model selection, model averaging, measurement error models, and semi-parametric regression.
Okay, thank you, Sam, for the introduction. Can everyone see my screen?
Thank you so much time for giving us the introduction. Yes, it's only taking up about half of the screen, so if you want to make the window a bit bigger.
So the font is too small? So I cannot see my own screen, so...
Oh, no. That's better. Yep.
Okay. Yeah. Sorry, I didn't make a notebook, and I haven't got the time to really save my document. So it's purely just Julia script, and due to time, I think I'll just maybe emphasize a few points. And that's the benefit of speaking after Shannon, because we already know some background of the problem. So I think using Julia, the one thing I'd like to mention is Julia is very easy to manage the project. So for example, in this script, I used this many packages corresponding to specific versions. And all the information, all the packages, especially the corresponding specific version, are stored in the TOML file. And if you just want to use it to activate this project, you just need to use one line of code so that all the project information will be just imported. And then if you got this file from other, for example, I'll post this online later, then you just need to really just instantiate it just using one command line. Then all the packages will be just installed with a specific version that I just used. That's the first point. And I think that whenever we work with data, the first step would be really just to reading data. And in Julia, I think if you are given just raw, say, CSV files, the most commonly used package would be this data frame. So I can just run this line, and to reading the file is already efficient enough, but just because for this data set itself is not a very large data, so the timing wouldn't be an issue. But just as the plenary talk mentioned, sometimes you need to work with very large data set. So you may want to, after pre-processing the data, you probably want to just load and save the data in the future in a much faster way. And for that one, you can use this arrow format, which is the APAC standard, and that can be used and accessed from most of the languages, including R and Python. Okay. And another new format, relatively new, is the JDF format, and it's just a JDF package in Python. And one advantage of this data format is the data are actually, if you can still look at my screen, as a separated file, which means each individual columns are stored in one file. And this just means that in the future, if you just want to load part of the data, you can just specify the columns you want to use. And for this data frame, it also has all the corresponding functions to just look at data. And for me, a typical thing I'd like to do first would be just to describe the data and get certain information about the data. For example, we can see clearly that for certain columns, over 99.9% of the data are missing. So those columns may not be really that useful. And so for the first task, we need to really change the names of the data set. So which can be done just by using this rename function, and we just like to make the corresponding column name to be a lowercase. So due to time, let me just keep going. Oh, and for missing data. So there are certain rows that we only have the address. Okay, so we can easily find for those rows. We only have the address, but we have the coordinate missing. And in Julia, we have this package is geocoder. For this one, we also need an API key, so it's better that I don't show my API key here. So I just put it in this file. And what this package provides is it provides a function so that if we are given any address, we can just use the either OpenStreetMap or the Google Map API just to find what are the corresponding latitude and latitude. And here is just the corresponding for loop I use to extract those latitude and longitude. And Julia also has an option so that, for example, here is just checking that this code will only run if I run this whole script as a main file, because I don't want to spend the time to wait for this code to run here. Let's say if I have the data all imported and I'd like to create a column of duration because when I read in the corresponding data, I already specify the data format. So the corresponding reporting and closing date are already stored as a data format. So I can just do operation on it directly to create this new column. So let me talk a little bit about plotting. So this is one thing I like. In Julia, I think I use this plots more often. Let me just show. So by default, this would be something looks like. So this is just really the corresponding density plot for the weekday and the weekends. We don't see much of a difference, but we do see we like to look at a certain region, and that might have something interesting. But this figure is not very dynamic. But for Julia Applause package, it provides a very nice property that we can easily change the backend. For example, I'd like to change the backend to Plotly.js. Then I don't need to change my code. I just change the backend for plotting and using exactly the same code. Then the corresponding plot. Oops. It's just plotted using the Plotly, and which is very interactive. You can easily just get a look at the interesting part of the figure, and we can just easily move those. We can get immediately feedback. I find this very nice, especially in my teaching. Often a time when I prepare my notes, I just use this GR, the default backend for fast process. And in class, when I talk about some result, I'd like to do it more interactively. And it also provides, say, multiple plots. For example, if I now change the plotting background to PyPlot, then the figure will be just plotted using the Python matplotlib. I think due to time, it's better that I'm moving. And there's a new initiative that is corresponding the so-called Mikey. It's relatively new to me too, but it seems in the community, people has been making a lot of effort developing this, and it's also make the corresponding result more interactive. And it seems this is something that will become very popular in the Julia community. Let's keep going. And if we want to do a hypothesis testing, there is also a hypothesis testing package. We can do, say, a t-test, which we have the same result. Really for the duration in weekday and weekends, we don't really have a significant difference. And we can also do non-parametric tests, which really shows us some difference. The reason is really the corresponding distribution are really either skewed or we can see a lot of outliers. Another thing I'd like to mention is, for example, because Julia is relatively new, there are a lot of packages that are not exist, but it's very easy to use existing package in existing languages. For example, I'd like to impute the UX sensor data just as Shandong did, but I don't have a Julia package at the moment, say, but I can just use a Python package. And in order to use that, I can simply just use this PyCar and use this PyImport to import. This is really the corresponding Python module. And now it is really imputed into Julia. And I can just do a quick search. Say I can search by a zip code, and it gave us the corresponding data information for this zip code. I can also search the corresponding data using the coordinates. And this part is really the corresponding code I use to find all the corresponding data. And it's also, I also noticed that there are certain coordinates that we do not have really the corresponding exact matching in the US sensor dataset. If we want to feed a model, we can use the DRM model, and the author is dog-based. So this package is really very nicely done. And here I'd like to just show one example that in this case, if I use those variables, there are some cardinality issues. Some variables are not really estimable, but for this package, actually is just like SAS, just says something as a constraint and then give us a corresponding valid estimator for other parameters. And we can also find the corresponding evaluation of the accuracy. Another thing I want to mention is in Julia, we can feel free to write our own function. For example, I'd like to calculate the corresponding AUC. So due to time, let me just show just one version. And then let's just quickly check the corresponding time. So it just take about 0.005 seconds also to calculate the corresponding AUC. At the same time, there are also multiple packages. They also provide the corresponding function, for example, here, to calculate the AUC. And if we just take a look, we can see that actually using our hand-coded function, actually, we are not really slower than the well-engineered function. So, and this actually happens a lot, which means using Julia, you can feel free to write your own implementation, and it's often possible that actually your own particular function actually is faster than any existing package. And also, I think I create a log curve, and let me change the, I'll just, and I can also feed XGBoost and then do a quick comparison to compare the performance. And this is based on XGBoost. It's also a tree-based, and this is based on a logistic regression. And due to time, I think it's better that I just stop here now. Okay.
Thank you very much, Haiying. That was great. And again, just for everyone in the chat, please put your questions there. Yes, give Haiying your virtual high fives. I love that feature. And yeah, put your questions in the chat and we'll be answering them at the end. So all three of our speakers will get together and answer questions at the very end.